We are all aware that finding life in the solar system, and specifically on Mars, is somewhat of the holy grail of human space exploration. In reality, an emphasis that is typically only saved for the noblest endeavors is a part of almost every mission that begins with the intention of landing on another planet. And this is a sign of how strong and pervasive our species need to not feel isolated in this vast cosmos is. And someone in NASA's high management or another space agency must have known this for some time. So much so that the word life has evolved into a secret phrase that more quickly than others unlocks government subsidies and draws the interest of a generally disinterested populace. In fact, it's comforting to know that a significant government agency like NASA has a commitment to the hunt for extraterrestrial life in its charter. It gives us confidence in our convictions. One thing, though, that not everyone is aware of is that the Viking probes were the last actual interplanetary expedition designed and launched to look, for life on Mars. In pursuit of signs of microbial life, the two NASA landers conducted site-specific biological experiments in 1976, the only time life has ever been attempted to exist on Mars. Contrary to what NASA said, many biologists still feel that these experiments were successful today. Since that time, mysteriously, despite the excitement that surrounded the departure of every single Martian mission, none of the subsequent landers or rovers launched by NASA to Mars have taken with them an instrument capable of pursuing those contentious but fascinating results. In other words, NASA has mostly given up seeking for life on Mars for the past nearly 50 years. The idea that the goal of Martian exploration was to discover or rule out life has persisted throughout the years, yet the sent probes were wholly unable to carry out the task for which they were introduced to the world. The purpose of the Viking missions that followed was to explore the Martian environment from a geology perspective, not to determine whether or not there might be microbial life in the Martian dunes. Not only that, though. The majority of people that are enthusiastic about space exploration definitely aren't aware of something else. The Martian rovers have never been allowed to come any closer than 2.5 kilometers from particular locations where life might have had the chance to discover the ideal conditions to establish, despite being entirely inappropriate for the hunt for life. In actuality, while the media was advocating the chant "Let's go looking for life," the agency sent on Mars rovers appropriate only for geological exploration, and moreover in locations completely arid and far from the outcropping spots of liquid water. The explanation? The Planetary Protection Procedure. A global organization called COSPER, Committee on Space Research, establishes protocols for the protection of the planets to which the United States, Europe, Russia, and other signatory nations that are going to travel in space must adhere. In fact, the Outer Space Treaty of the United Nations has prohibited the dangerous contamination of other worlds with terrestrial biological forms since 1967. Since 2002, COSPER has set aside a few restricted special zones on Mars where the climate may be favorable for the survival of Martian organisms or intrusive terrestrial species. Brackish water flows from aquifers during Martian summers in special locations that have been clearly found near the equator and in the mid-latitudes of the planet, and eroded in steep gullies, rocky slopes, and craters. Perhaps in caverns, beneath polar ice caps, and in seismic or volcanically active geothermal hotspots. For fear of eradicating or causing the potential Martian life form to hybridize with terrestrial bacteria, no human artifacts are permitted to approach any of these locations. And before every launch, spacecraft are meticulously sanitized to prevent the accidental transfer of terrestrial organic material. However, it has been discovered that there are some microbes on our planet that can withstand even the most ferocious sterilization as well as the harsh conditions of interplanetary space during the Earth-Mars crossing. In fact, it appears that it is impossible to completely rule out the possibility that some bacteria may awaken once on Mars and seek refuge in the planet's most humid and hot regions. The research, conducted by astrobiologist Andrew Schwerger and colleagues at the University of Florida, has actually confirmed that some terrestrial microbes may survive and reproduce in a Martian environment that has been artificially recreated in the lab. Serratia liquefaciens, a common terrestrial bacterium found on humans, animals, and plants, was kept in chambers with pressures of 7 millibars. On Earth at sea level, pressures are around 1,000 millibars, a carbon dioxide-based atmosphere. Without oxygen, temperature at 0 degrees Celsius, and no humidity. This was done to demonstrate that a common terrestrial bacterium could take root and multiply even in the harsh environmental conditions of Mars. But what about humans, if sterile robots can't be trusted to explore restricted areas? The idea that NASA intends to send people to Mars by 2030 may present contamination dangers is presumably not something the organization wants to emphasize at a time when it is actively researching potential solutions to the issue. Not least because it would be challenging to justify to the general public why a human mission costing tens of billions of dollars should be prohibited from the most promising areas from the standpoint of biological research. And would they have to leave right away, pick up the rocket, and go back to orbit if a human crew who had been sent to a location that had been ruled unfit for life later discovered it to be habitable or that there were living things there? These and other unsolved concerns highlight how, depending on the circumstances, the discovery of a Martian ecosystem might be either NASA's greatest hope or its worst nightmare. Up until now, robotic exploration has been the focus of planetary protection on Mars. Machines are likewise susceptible to infection, but unlike people, they can withstand being exposed to radiation and strong chemicals prior to launch in order to eradicate covert microorganisms. Under these presumptions, however, planetary protection would eventually come to completely exclude the human exploration program and any potential scientific benefits. And if it had been used 60 years ago, even the historic moon landings would have been destroyed. Remember, the first astronauts left several hundred pounds of metabolic waste at 6 separate locations on the lunar surface. That is, dozens of bags of waste materials like feces, urine, vomit, and food. The idea is that those waste products might have contained thousands of microbial species, which makes the greatest act of human exploration appear more like the following day of a party. Who's to say that at least one of them didn't succeed in carving out a space for itself where it could reproduce? After all, bacteria were discovered on the moon by the astronauts of the Apollo 12 mission, having survived a near vacuum inside the robotic lander Surveyor 3 that had landed there more than 2.5 years earlier. Why couldn't some of Mars' more livable regions be home to terrestrial bacteria if environments like those are suitable for them? Whether or not the general public is aware of it, the application of this concept of caution has been done so meticulously over the years, in part because there has always been the hope, perhaps false, that they could genuinely sterilize equipment and rovers launched into space. But it becomes impossible to uphold the same standards now that the human element is likely to reappear. The human body is full with bacteria that may make it impossible to complete a mission, at least in accordance with previous criteria, no matter how cleaned and sterilized it may be. So as to boost the tolerance levels for human contamination, NASA has handled the issue by downgrading some portions of the moon, but not Mars. The moon was once categorized as a Category 2 body, but is now nearly totally a Category 1 body, where no protection is needed because no life forms are predicted to be found, remote possibility that contamination by terrestrial means could compromise future missions. This classification had been made after theories regarding the existence of water masses on the moon had been put forth. However, it is now only used in a few extremely precise locations where there are shadowed craters that could contain icy regions. Hence, it becomes simpler to investigate the majority of the moon. Instead, there will be no change for Mars. It has been determined that the entire planet is a Category 4 body, high risk of contamination, with some particular locations being even more protected. A policy this rigorous raises more than a few questions about the possibility that Viking did detect Martian life 50 years ago and that NASA or whoever was responsible for it intended to attach the state secret label to the discovery. Yeah, that's probably just a fantasy. What is real, however, is the emergence of a segment of the scientific community that openly rejects NASA's overly cautious policy and campaigns for the space agency to adopt less stringent regulations that are compatible with both the legitimate exploratory goals of future human missions and the protection of a potential Martian ecosystem. Astronauts from Earth will depart for Mars equipped with housing, 3D printers, food, and tools, as well as life support and energy supply systems. None of these items can be disinfected in the same manner as robotic spacecraft-related devices can. Human colonists will create garbage, attempt to cultivate food, and employ machinery to draw water out of the ground and environment. Simply put, human colonists will contaminate Mars by living there. Jose Lopez, a microbiologist, argues in a recently published study that efforts to enforce planetary protection provisions are actually absolutely unneeded and possibly even quite stupid. By exchanging meteoritic material, Mars and Earth must have been polluting one another for many billions of years. Lopez and his co-authors contend that rather than being concerned about contamination, we should intentionally send our bacteria into space and that their expansion should be a part of a bigger colonization strategy to alter the climate and environment of Mars. In reality, the authors of the article are persuaded that it may not be possible to stop our germs from colonizing the places we are exploring. As a result, they believe that it would be more sensible to start talking about how to use microorganisms to our advantage than to run the risk of slowing down colonization out of an excess of caution. In short, the situation is extremely challenging, but despite all the unknowns, one thing is crystal clear: putting the planetary protection provisions into practice in order to send astronauts to Mars will raise significant issues regarding science, engineering, technology, project management, and public policy. Not to mention the ethical dilemma, which must be seen as the underlying reason for all of this resistance to view the bodies in the solar system as new regions of our full importance. According to well-known astronomer and popularizer Carl Sagan, Mars should belong entirely to the Martians, even if they were simply bacteria if life were ever discovered on the fourth planet. According to this viewpoint, the planet would be viewed as an unreachable sanctuary where humans would never be allowed. To stand in its entirety, however, a demonstration of ethics must first confront another Holocaust, the hundreds of billions of sentient individuals slain annually on Earth for our food vices. Why do our creatures not deserve to survive when Martian bacteria do? The Perseverance rover is about to land on Mars in the meanwhile. Even in this instance, the mission's primary goal will not be to trawl through the brackish water springs and use chemical reagents to detect the existence or lack of microbial life. Instead, the rover's job will be to gather soil samples from Mars, strictly outside the special zones, and leave them in the sand in big tubes while they wait for other missions to arrive and bring them back to Earth. Do you know when? After 10 years. How do you feel? Don't you think NASA is merely attempting to stall? Let us know in the comment.